Hello guys, and welcome back to my channel. So today we'll be working with Brachistochrone problem, which is the same thing as the shortest time of descent problem. It's just saying how when you have two different points, which route is the shortest path to take. That is what the problem is talking about. So I can have point A and point B. I can decide to pass through these routes, or a straight line, depending on any direction I want to pass through. But this problem is telling us how you can determine the shortest distance to pass through when moving from a point to another point. So it's the same thing we have here. So let's say we have point A and B, and then we're looking for the shortest route to pass to reach B. So from A to B, I'm looking for the shortest route to pass so that I'll connect A and B. Now the first thing is I will have to look for the time taken for me to move from A to B. Now if I'm looking for time taken, then I'll have to start to recall from physics that velocity is equal to distance over time. Now if I have velocity to be equal to distance over time, then I can write it mathematically that velocity equals the s over the t, which is change in time, distance over time. Then I can make the t the subject of the equation or the formula. So dt equals the s over v, and if I cross multiply, I have t equals the s over v. Now you then recall from length functional that you have distance, the s, to be equal to root of 1 plus y dy dx. If you have y prime, it is the same as dy dx, so y prime all squared dx. If you feel this is strange, I've explained this before in the previous video, so you might probably need to subscribe and then turn on your notification button so that you get notified immediately we post videos regarding this. So I've uploaded a video on the explanation of this, so you can probably go through the videos I've uploaded before to check through how I got this. So here your ds is equals to square root of 1 plus y prime squared dx. So therefore it means I can just equate this into the formula I have initially. So dt will just be equal to, instead of writing the s back, I'll have 1 plus square root of 1 plus y prime squared dx over v. But then I still need to look for v, right? I can't just use v straight up like that. So for me to get v, it implies I'm going to have to look at, okay, the total energy. I'll have to look at the principle of conservation of energy, which states that, okay, we're going to have to subtract the total energy at point P minus total energy at point A and equate it to work done. So if we're doing that, it implies that I'll come back to my graph. The energy at point A is at rest. Let's say, for example, this is a mango tree, and then I have a mango here. This mango is at rest because it's not moving unless it falls down or it drops on the floor. So if it's going to drop, it means it's already undergoing another kind of energy, but at this point it's undergoing potential energy. That means the energy is at rest. When it's coming down, it's undergoing kinetic energy. So the energy here equals 0 because it's not undergoing anything. But when it starts to flow down, the energy, kinetic energy, sorry. So when it falls down, then the energy will be equal to kinetic energy, which is energy in motion, right? So therefore, and the kinetic energy is equal to half mv squared. That is why here we have the energy for at point P to be equal to half mv squared, at point A equals 0, and then we now say work done in physics is equal to mgh, mass times acceleration due to gravity times height. But instead of using height here, we'll be using y. So I have it to be half mv squared equals mgy. Now half mv squared equals mgy. I'm looking for v, so I can make v stand alone. I multiply by 2 first, and then I divide both sides by m. So I have v squared equals to 2gy, but I'm looking for v, not v squared. So I can just automatically take the square root. Inverse of square is square root, so you square root both sides. If I square root both sides, I have v equals to square root of 2gy. Now I already have v. I'll go back to this equation, right, and then equate. Anywhere I have v, I don't just put v, I put the value of v, and now I've gotten that the value of v equals square root of 2gy. Hence the time spent will then be dt equals square root of 1 plus y prime squared dx over square root of 2gy. If I integrate both sides, dt, if I have integral of dx, it will give me x plus c. I have x back. If I integrate dy, I'll have y. It's just the same thing as d of y. So if I integrate, I'll have y back. So same here, if I integrate dt, I'll have t. Now, taking the integral from 0 to x1 of 1 plus what we have on the right hand side. So I can bring out the constant because I'm integrating with respect to x. So I can just take this part, which I can just call irrelevant. So 1 over square root of 2g to come out. Using indices, I can bring this out. It's still the same thing. So I have square root of y here. So now I have to recall, I've explained all these few things that I'm typing here. That's why you might probably have to subscribe and turn on a notification bell so that you get notified when I drop or upload videos. I've explained something related to this before, and I know you would like to watch it. So coming back to the explanation, I said now you have to compare this because we have to integrate. We have to solve the problem. We'll have to extremize, and if we're extremizing, we'll be using Euler's Lagrange equation. So therefore, I'll have to recall that, okay, I have integral from 0 to x, f of x, y prime dx. So if I have this functional, it implies that this is called a functional. So it implies that, look at it, if I compare integral from 0 to x, it implies this is equal to this. So if this is equal to this, I can tell you that my f of x, y prime equals 1 plus y prime squared, all raised to power half. This is the same thing as me saying square root of 1 plus y prime squared over square root of y. Half is the same thing as square root. So since we have that, then we can now extremize. Like I said, after having this, you have to recall that we have Lagrange equation. Using Lagrange equation, second Lagrange equation, we have f minus y prime di f di y prime equals c. So your f is your functional, this functional we have here. Now, then I'll have to differentiate partially with respect to y prime. If I differentiate partially with respect to y prime, it implies that I will have here, this is it. I ensure I explain vividly so students don't have problem when they watch my videos. Now, I can either use quotient rule or I use product rule. I can change this to this, multiply by 1 over square root of y. If I have 1 over x, it's the same thing as what? X raised to power minus 1. So I can tell you that this is the same thing as 1 plus y prime squared, 1 plus y prime squared multiply 1 over y raised to power half, because anything raised to power half is the same thing as square root. So this is the same thing as 1 plus y prime squared raised to power minus, multiply by y raised to power minus half. So when I have that, I can just bring this down. Watch few of my videos. I've explained product rule in a very simple way, using the shortcuts and other things like that. So if I integrate this with partially with respect to, we're looking for di f di y prime. So I'm integrating partially with respect to y prime. So anywhere I see any other thing that is not y prime, then I call that a constant. So if I integrate 1 is a constant to be 0. Differentiate, excuse me. So if I differentiate 1 is a constant to give me 0. If I differentiate y prime squared, it will give me 2y prime. Now I come here, if I differentiate y partially with respect to y prime, this is a constant because it is not y prime, so this will give me 0. Then if I cross multiply, this will turn to if I cross multiply, this will turn to 0. Okay. Okay, I think there's a mistake. Let's do this gently. So we didn't complete it. It should have half here. So let me take a plain sheet, so a plain space, so we're able to integrate and differentiate well, and then you understand what I'm trying to explain. So now we want to differentiate this with f partially with respect to y prime. So we're looking for di f di y prime. So here, since we have f to be equal to this, so I told you we can just write it as 1 plus y prime squared raised to power half multiplied by y raised to power minus half. So I bring this down using product rule, right? I've explained this before in some of my videos. You watch other videos to understand better, but then I'll still explain here. So I said you have to differentiate with respect to y prime. Any other thing that is not y prime here is a constant, will be treated as a constant. If I differentiate this to give me 1, to give me 0. Before we differentiate this, you use chain rule to differentiate this. Then we have a shortcut for chain rule also. So what you just do here is bring down the power. You have 1 over 2. Differentiate the bracket. If I'm differentiating the brackets, I have, this is 0, so I have 2y prime because I'm differentiating y prime alone, y prime squared. Then bring down the power, differentiate the bracket, rewrite the question, and reduce the power by 1. So this will be half minus 1 will be minus half. And if I differentiate y raised to power minus half, because it is not y prime, I take this as a constant, so this will be 0. Then I can cross multiply. If I cross multiply, this will be 0. Then this times this will be half cancel half. So I have y prime 1 plus y prime squared raised to power minus half multiplied by y raised to power minus half, which is the same thing as y prime over square root of 1 plus y prime squared multiplied by square root of y. Excuse me. Since we have negative here, so they will all come down. If you have x raised to power minus 1 is 1 over x. So that's what we have here. So after differentiating with respect to y prime, you have this. That's why you have this here. So you have this. Now I can put it into my Lagrange equation, Euler's Lagrange equation, excuse me. So I have f to be this, and impute it here. I have this y prime multiplied by di f di y prime. This is it. So now I can take the LCM. If I take LCM, this is the LCM, square root of y multiplied by square root of 1 plus y prime squared. So if I divide this by this, I'm left with just this alone. So if I am left with just this alone, I multiply by this. So it means I'm multiplying square root of 1 plus y prime squared multiplied by square root of 1 plus y prime squared, which is same thing as 1 plus y prime squared raised to power half multiplied by 1 plus y prime squared raised to power half. So I'll take one law of indices. If I have x raised to power 2 plus times x raised to power 2, it is x 2 plus 2. So here I have 1 plus y prime squared everything raised to power half plus half, which is half plus half is 1. That's why you just have it to be 1 plus y prime squared alone. So the same thing here. Then minus your y prime times y prime, which is y prime squared over this back. So y prime squared minus y prime squared will go because it's turned to 0. So I can tell you that I have just 1 over square root of this equals c. Then I cross multiply because I cross multiply. When I cross multiply, I square both sides. Why am I squaring both sides? Because I'm trying to eradicate anything that has y prime. I'm looking for y. I want to reduce it and then have y alone. So I have to find a way to this is inside a cage already, your y prime, so I have to lose it away from the cage. So if I square both sides, square root, opposite of square root is square. So if I square both sides, square root to cancel, all the square roots cancel, and then we'll release it from its cage. So 1 squared is 1, c squared y, because square we have this alone left. So now I told you I want y prime alone, so here I can have 1 over c squared equals y into 1 plus y prime all squared. So now I now say this is k1. because I don't want to be writing 1 over c squared. So I can just tell you that where k1 equals 1 over c squared, another constant, a constant is equal to constant. So I have k1 equals to y into brackets 1 plus y prime squared. So now I can divide both sides by, because I want y prime to stand alone, so I'll be able to reduce it and integrate if possible, and then have it to just be y. So I have k1 over y equals this. So I can just, I can bring my 1 to the other side. So I'll have k1 over y minus 1 equals y prime squared. Now I don't want square. This square is also cage and is making this thing look as if it is inside a cage. So I have to do the opposite of square. And the opposite of square is square root. So I square root both sides. When I square root both sides, I'll have y prime to stand alone. So when I square root both sides, I have square root of k1 minus 1 over y, k1 over y minus 1 equals y prime. So I have this. Then y prime is the same thing as the y over the x. So I have this. So I want y and the y to stay alone in one side, the x to stand alone on the other side. So I'll be able to, I want to use separate it. So I'll be able to integrate. So now what you just do here is interchange. So you can say the x over the y equals, I'm just trying to explain vividly so everybody understand, square root of y over k1 minus y. You take LCM here, that's why you have it like this. So you've interchanged already. So you can take the y to the other side. So you cannot say the x equals square root of y over k1 minus y dy. So that's what we just did here. Then you can, now they are standing alone. Now since they are standing alone, you can now integrate. So you can now integrate. When you integrate, by integrating this and then this. So if you integrate, if you integrate the x, it's just like when you are integrate the x. I've explained this before. You just have x, but then you must introduce a constant. So I don't want to use k1 again. I'll use k2 instead, so that I'll be able to differentiate between k1 and k2. They are two different constants. So then if I want to solve this left hand, I've solved the right hand side, but I want to solve the left hand side, then I'll have to use few things, and I've explained some of these things before in few videos that I've uploaded before, so you can just check through. Always note that you probably have to subscribe, turn on your notification bell, and then if you really do understand and enjoy the explanation, do me a favor by liking the videos. Thank you very much. So you have to subscribe and then turn on the notification button so that you're able to get videos that I've uploaded. I've explained few things before concerning this. So now you let y equals to k1 sine square t, such that your t is in this boundary, t is greater than 0 and less than pi over 2. So that's 180 over 2, which is 90 degrees. So if your y is k1 sine square t, now what is the y dt? This thing is the same thing as using what's the name of this rule? I said it before and I've forgotten. Sorry. So k1 sine square t is the same thing as k1 sine t all squared. So if I want to differentiate this, the y dt implies bring down the power, right? So I told you guys, I've explained this before. Quotient, no, not quotient, chain rule. Bring down the power, differentiate the brackets. If you differentiate sine t to give you what? Cos t. Repeat your bracket sine t and reduce the power by 1. 2 minus 1 is 1. So you should be having 2. Don't forget your k1. So you should be having 2k1 sine t cos t. Alright. So now your k minus y, just recall that sine square t plus cos square t equals 1. So your cos square t equals 1 minus sine square t. So if you have k minus y, it's the same thing as k minus k sine square t. So this is like k 1 minus sine square t. So this is k into 1 minus sine square t is what? Cos square t. That's why we have here it to be k1 cos squared t. I hope you understand, because I'm trying my best to make sure you explain it in a very, I don't know, the least way I can explain, so everyone will be able to understand. So going back to this equation, it implies anywhere I see y, I don't just put y again. Since I already know that I said my y equals k1 sine squared t, I use y. Then I've differentiated. I told you that the y is this. So what else do we need? I said this is also this. So we just have to impute everything back into the integral. So imputing, we'll have this k1 sine squared t over k1 sine cos squared t times 2k1 sine t cos t dt equals x plus k2. So now I can say this is the same thing as this, because I just want this square root to cancel. So square root cancel square root. I'll be left with sine t over cos t equals to tk1 sine t cos t dt equals to x plus k2. Now cos t will cancel cos t, sine t times sine t will give us sine squared t. Don't forget your 2k1 dt equals to x plus k2. Then recall that when you have 2 sine squared t, it is equivalent to 1 minus cos 2t under trig. So in mathematics, yeah, I know we're doing mathematics, right? But then I still have to mention mathematics. So we have here, instead of sine squared t, 2 sine squared t, I'll have 1 minus cos 2t dt equals to x plus k2. So I'll be able to integrate, because here you can't integrate like this except you expand in this manner. So I'll be able to take integral of each. So integration, if I integrate 1 with respect to t, I'll have t. If I integrate cos 2t, you take reciprocal. What you first do is differentiate what you have in front. Differentiate 2t. That's 1, that's 2, right? So you take the reciprocal. That means we'll have 1 over 2. Then differentiate your cos. We have sine. Then you write your question back, 2t. If I have cos 3t and you want to integrate, or 3t squared, you first differentiate what you have in front. So 3t squared is like 2 times 3t, that's 60, right? So you take the reciprocal, you have 1 over 60 multiplied by cos is what? Sine 3t squared. That's it. So just write your question back. So I hope you understand the fast explanation I just did here. So after integrating this, you have this back equals to x plus k2. Now you can now have x, because all you just do is make x the subject of the formula or of this equation. So you take k to the other side. That's why I have minus k2. This minus k2, I can decide to give it another constant again. Like I don't want it to be minus k2. I can tell you that it is equivalent, it is equal to k2 again, or k3, where my k3 equals to minus k2. See, so that's anyhow you want to do it. So I'll prefer leaving it like this. So similarly, you recall that you said y equals to k1 sine squared t. So now you can say y equals to k1. When you have sine squared t, same thing as 1 minus cos 2t. So you have y equals to k1 minus k1 cos 2t. Now these two equations here are telling us that when we were solving this equation from the beginning, the problem, we said we're looking for the shortest distance, the shortest wave line where we can use to move from A to B, right? So now these two equations are telling us that the shortest distance that you're going to use is a curve called a cycloid. It is not just a straight line. We'll be using a cycloid. So this cycloid is something like this. I just tried I don't know, an explanation. So if you have like a ball and then you attach a pin with a thread to that ball, allow it to roll, the kind of shape is going to form is something like this. So that kind of curve is the kind of curve we're going to use. Is the kind of curve, or the curve, or the kind of distance we're going to use to move from A to B. You'll be using a cycloid. So the shortest distance is known as a cycloid. When you want to move using what? Solving the Brachistochrone problem, we'll be using the distance we're going to be moving is a cycloid. So that is just the explanation to this. If you really do enjoy the explanation, do well to please like, subscribe, and also if you have any questions, you can drop it in the comment box. I'll make sure I reply. And then if you have other videos you want me to make, you can drop it in the comment box. We'll definitely reply. Thank you so much and have a nice day.